Okay, a couple of new definitions, kind of. All right, so start by drawing a circle up here. Now we got a word here, it's a chord. We talked about it. All right. So a chord is a segment whose endpoints are on a circle. So that's a chord. There's a lot of different chords. That's just one of them. There are some theorems today dealing with chords. So the first theorem says in the same circle, two minor arcs are congruent if and only if their corresponding chords are congruent. So go ahead and draw another circle here. And I want you to draw two chords that are the same length. So there's one, and if I come over on this side and I draw that one the same length, I'm going to mark them congruent. This theorem says that these chords can only be congruent if these arcs are congruent. And vice versa. These arcs will be congruent only if these segments are congruent. Okay? Let's apply this theorem really quick. Example 1 says if PQ is 16 centimeters, find QR. So PQ, which is right here, would be 16. So let's go ahead and label that 16. And we want to know how long is QR. Well, we're given some other information. We're told some arc measures. We know this is 155 degrees, and this is 50 degrees. And what do all the arcs have to add up to? Okay, so we can find, because we can't really find anything else, we can find the measure of arc PQ. So measure of arc PQ, well, that would be 360 minus 155 minus 50. Okay, so we're subtracting everything from it, right? And so we get 155. So this arc over here must be 155 degrees. Now, according to this theorem, if we have congruent arcs, then we must have congruent segments. I'm sorry, congruent chords, not congruent segments, congruent chords. And so since, I'm going to say since the measure of arc PQ is equal to the measure of arc QR, segment PQ must equal segment QR. So then that means what? So QR must be how long? 16 centimeters. Now notice how we had to find the missing arc to make sure they were congruent. We just can't assume they're congruent. We need to double check they actually are. If they're not, that means we need something else. All right, the next theorem, let's start off by drawing a circle. In a circle, if a radius is perpendicular to a chord, then it bisects both the chord and its arc. Okay, so let's start by drawing a chord. Just make one easy enough right there across the top. It says if a radius is perpendicular to that chord. So if we draw a radius, that's be starting in the middle, all right? And it's perpendicular to this chord, so in this case it would just be going straight up, and there's a right angle. Then it bisects its chord and its arc. Now the word bisect means cuts in half, which means that this must be congruent to this, right, the segment. And this must be congruent to this. And if we do the converse of that, the perpendicular bisector of a chord has to go through the center. So if you're ever trying to find the diameter of the circle, the easiest way to do it is you draw a chord, then you draw the perpendicular bisector of that. And that's their diameter. Okay, so let's apply that theorem. So we're told that CB is perpendicular to AD. Okay, now notice that CB is a radius, right, and AD is a chord. So based on that one statement, based on this previous theorem, we can conclude that CB is bisecting AD. So that means this must be congruent to this, right? AE is congruent to ED, so I'll write that down. AE is congruent to ED. And these arcs must be congruent. So I'll say arc AB is congruent to arc BD. So that just this initial statement tells us those two things. So we're told CE is 7. So that's here. CE, so that's this side right here, 7. And the radius is 10. All right? So what is AD? How long is AD, chord AD? Well, let's see. The radius is 10, so that means CB is how long? 10. Okay. How long is CD? So that's also radius, so that must be 10. And notice that if this is a right angle, then this must be a right angle. So what shape do we have right here? Right triangle. So we can find ED. Right? And if we find ED, we know AE is the same because they're congruent. So we can find ED, Pythagorean theorem. So which one's the hypotenuse there? Okay, so we've got 10 squared minus 7 squared. And that comes out to 7.141. So if ED is 7.141, we know that AD is 2 times ED. This chord from A to D is 2 EDs, because these are the same. And so 2 times 7.141 gives us 14.282. And then our last theorem is another circle. So go ahead and draw another circle. And this time I'm going to label some points on our chord. So it says in the same circle, 2 chords are congruent if and only if they are equidistant from the center. Okay, so I'm going to go ahead and put a chord right here. I'm going to call that chord AB. And I'm going to put a chord over here which is the same length. If we don't know it's the same length, but it's going to be CD. And it says they're equidistant from the center. So that word equidistant, I'm going to take a guess at what that means. Equal distance, yep, same distance. So if I go to the center here, the way we find the distance from a point to a segment is we draw the line perpendicular to the segment. So if I just come here, that's perpendicular. Come here, that's perpendicular. And so if, I'm going to rephrase that. These 2 chords, AB and CD, are congruent if and only if this is congruent to this. In other words, if this length from here to here is the same as this length from here to here. That implies that AB is congruent to CD. And vice versa. If we know AB and CD are congruent, then this distance must be the same as this distance. So again, let's apply this theorem. Let's see here. EF is 5. Let's label that. EF is 5. The radius is 13. So there's a lot of there's a couple different radii drawn here, right? This is a radius, so this is a radius, and this is a radius, and this is a radius. They're all 13. Okay, so I'm not going to label anything just yet. CG is 12. So CG, so that would be this segment right here is 12. Okay, now we want to find AB. How long is that? All right. So in general on these problems, you want to find anything you can. You may not be exactly sure what you need, but see if we can find something here. Let's see. Well, we know, and usually you want to look for triangles and stuff. So we've got a triangle right here. Is this a right angle? Okay, so we have a right triangle. So if we knew two of those sides, we could find a third side, right? So how long is FD? So we can say EF is congruent to FD. How do we know that? How do we know it's being bisected? Okay, so the previous theorem said if we have a radius that's perpendicular to a chord, then it must be bisecting that chord. So that means this must be congruent to this. So that's good. So we know FD is 5. And then we're also told the radius is 13. Well, CD is a radius, so we've got 13. So can we find CF? Okay, so let's go ahead and find CF. So CF would be the square root of 13 squared minus 5 squared. And conveniently enough, that comes out to 12. Exactly. So CF is 12. So based on this theorem, right, if we look at this, the distance from the center to chord ED is equal to the center to chord AB, right? So I'm going to say CF is equal to CG. So what conclusion can I make? So ED must equal AB, right? For equidistance. Equidistant. Well, how long is ED? ED is equal to 10. Why? Well, because we have two 5s. So, how long is AB? Also equal to 10. So when you start working on these problems, find whatever you can. You never know what's going to lead you towards using one of these theorems. Okay, you're not given all the information, so you've got to find what you can and then apply it. Okay. There are 9 problems. I've got the key over here. You can check your answers periodically. Remember, you're using these 1, 2, 3 theorems. Okay. So as you're working, you should be looking for opportunities to talk about congruent segments, or congruent, not segments, congruent chords, or congruent arcs, for example. All right, or for the second theorem, you're looking for a radius that's perpendicular to a chord. So you can say it's bisecting. Or you're looking for 2 chords that are the same distance from the center, or some way to show that they're the same distance. Okay. So we can get started on that.